If you think that the pointers of the watch are coincident at 35 past 7, then you are mistaken. They coincide somewhere after the 35, perhaps near the 40 minutes. How to calculate it, we'll soon see. As it is clear here, the distance between three spacings, or the distance including three spacing between numbers, is 90 degrees. Thus, the distance between one space is 30 degrees. That is 90 over 3. 90 over 3. That is one space, two space, the third space. In general, the units of omega, the angular speed, is universally it is measured in radians per second. But this is a very fast speed for the pointers of the watch. So we'll use a unit suitable for us, and it must be, of course, angle per time. So let's start with the angular speed of the pointer of the clockwise of minutes. It covers, or it moves 30 degrees in 5 minutes. That is reducing, it is 6 degrees per minute. The hours moves the space between two numbers. That is 30 degrees per 60 minutes. That is 0.5 degrees per minute by reduction. Just to make things clear, a revision or clarification for units and dimensions. If omega has the units of angle per time, then omega times time is angle per time times time. That gives angle. And if we divide angle over time, that gives us omega. And conversely, of course, angle over omega gives time. Now, how to calculate when are the pointers collinear? Let's take an example. Here is the watch at 12:30. Think that they are collinear? Surely they are not. They would be collinear at somewhere here. How to calculate it exactly? We will not rely on our eyes. How to calculate it exactly? Yes, here how to calculate it. We'll start measurement when they are coincident at 12, where this pointer, the hours pointer, moved an angle. To calculate it, we have omega h, which we have calculated it to be 0.5 times t, and the minutes pointer, we calculated its omega to be 6 degrees per minute. So we'll start measurement from their coincidence on the 12 number. 6 times t minus 0.5 times t should be equal to 180, and calculate for t. We'll find where they would be collinear. That's it here. 6t minus 0.5t equals 180, and 6 minus 0.5, that's 5.5t equals 180. That gives t equals 32.7272 minutes. So here they will be collinear at 32.7272 minutes. Let's calculate another case, which is when would they be collinear after 1 o'clock. So simply we'll start calculating from when the time is 1 o'clock. When the time is 1 o'clock, we'll calculate 30 plus 0.5t, because the pointer have moved a bit far from the 1, and then the minutes pointer have moved from the 12 till here. So put in our equation 6t of this pointer minus 30 plus 0.5t should be equal to 180. Then here we have, as you see, by transferring the minus 30 to this side, we would have 210, and 6t minus 0.5t, we have 5.5t equals 210 degrees, which gives us t equals 210 degrees over 5.5, which is equal to 38.181 minutes. That's it, 38 minutes, 181 minutes, as you see here in this picture. Let's see another case. When would they be coincident? For example, after 4 o'clock. After 4 o'clock they would be coincident somewhere between the 4 and the 5, not on the 4, as I said before. So here Our equation would be, we'll start when the minutes pointer is at the 12 and the hours pointer at the 4. So we would have 1, 30, 30. The spacing between any two numbers, as I said before, is 30. So 1, 2, 3, 4. So that's 120 plus 6 times t minus 0.5 t equals 0. Counterclockwise pointers would be coincident after 20 past 4. Of course, we would not rely on our eyes, we would calculate it mathematically. We'll start measuring the minutes pointer 6 times t, starting from the 12, that is considers our 0, minus 1, 2, 3, 4. 4 times 30, that makes 120, plus this spacing 0.5 t. But this we would not equate it to 180, we would equate it to 0 because they are coincident. And substituting, we would have 120 equals 5.5 t, which gives us t equals 120 over 5.5. That makes 21.81 minutes. Here it is. Here they are. I could have just written forwarded the two main relations, the case of 180 when they are collinear and the case of their coincidence here, and left without examples, but I preferred to give examples to clarify things. That's all, dear audience. Bye.